Hi everyone, my name is Werner and I'm going to present polynomial equation and inequalities in chapter 2. So what is polynomial equations? Basically, polynomials, these words come from poly meaning many and nomials in this case meaning terms. So it is a many terms. A polynomial equations can have constant, variables and exponent but can never be divided by a variables. So these are the example of polynomials and these are the example of not polynomials. So what are inequalities? These are the example of inequalities. Equal to, not equal to, greater than and less than. Greater than and equal to, less than and equal to. So I'm going to present chapter 2.1, which is the remainder theorem. What is remainder theorem? When a polynomial function is divided by a divisor, the remainder is PB, and when it is divided by AX minus B, the remainder is P bracket B over A bracket, where A and B are integers and there is a restriction for A, which is A cannot be 0. So these are some of the basic knowledge about the long divisions, which is this is the quotients and this is the polynomial equation, this is the divisor, and this is the remainder. Quotient form. So what is quotient form? The result of the division of a polynomial by a binomial of the form x minus b. Px divide x minus p, get a quotient, and remainder divide by the divisor. The corresponding statement that can be used to check the divisions, which is px equal to x minus b multiplied by the quotient plus the remainder. Example 1. Apply and verify the remainder theorem. Use the remainder theorem to determine the remainder when px equal to 2x cubed minus 3x squared plus 8x minus 12 is divided by x minus 1. B. Verify your answer using long divisions. So, since x minus 1 equal to 0, the remainder is p equal to 1, p1 equal, substitute 1 inside and you get these solutions and we get a negative 5 for the remainder. So when this polynomial equation is divided by the x minus 1 divisor, we get a remainder negative 5. By using long divisions, the remainder is same as the example in A, which is negative 5. Example 2. Solve for an unknown coefficient. Determine the value of k such as 3x power of 4 plus kx cubed minus 7x minus 10 is divided by x minus 2. The remainder is x. So this is the solutions. Since we know when px is divided by x minus 2, we substitute 2 inside the equations and we get this. So move here, move there, and we get a k equal to negative 2. So the value of k is negative 2. Okay, chapter 2.1, which is factor theorem. So what is factor theorem? What if we calculate p bracket b and it is 0? That means the remainder is 0. And x minus b must be a factor of the polynomials. When pb equal to 0, then x minus b is a factor of the polynomial. When x minus b is a factor of the polynomial, then fc equal to 0. Similarly, ax minus b is a factor of px if and only if p bracket b over a equal to 0. If and only if. If and only if is a term used in logic to say that the result works both ways. Here, both of the following are true. If x minus b is a factor, then p bracket b equal to 0. If p bracket b is equal to 0, then x minus b is a factor of px. So x minus b is explained as integer zero theorem, which with leading coefficient 1 and remaining coefficient that are integers. Rational zero theorem, which is ax minus b. b is a factor of the constant term of px. A is a factor of the leading coefficient of px. For example 1, we can guess that the possible factor from the last constant, which is negative positive 1 and negative positive 2. We find it by 1 multiplied 24, we get 24, and 2 multiplied 12, we get 24, 3 multiplied 8, we get 24, and 4 multiplied by 6, we get 24. So for example 2, factorize x power of 3 plus 2x squared minus 5x minus 6 fully. First, we determine the possible factor, which is positive negative 1 and positive negative 2 and positive negative 3 and positive negative 6. Then we do it one by one if the function equal to 0. So I try 2 and it is equal to 0. Therefore x minus 2 is a factor of this polynomial equation. Then we can use two methods to find the other two factors, which is long divisions, syntactic divisions. So these are the long divisions. We get quotients and we put the divisor inside, a in the front, and we factorize the quotient to get the lowest one, which is fully factorized. So for method 2, syntactic divisions, we wrote it down the negative 2 here. So for the first digit in front, we wrote it down with the sign of coefficients. For the first one, we put it down and we multiply by here to here. So use this to minus the digit and get an 4. So 4 multiplied by negative 2, we get negative 8. And negative 5 plus 8, we get 3. So at here we get an 0. So it means no remainder. For example 3, solve a problem using the rational zero theorem. Factorize 3x cubed plus 2x squared minus 7x plus 2. First, let b represent the factor of the constant term 2, which are positive and negative 1 and positive and negative 2. Let represent the factor of leading coefficient 3, which are positive and negative 1 and positive negative 3. The possible value of b over a are positive negative 1 and positive negative 1 over 3, positive negative 2, and positive negative 2 over 3. So then test the possible value of 1 and we get 0. Therefore x minus 1 is a factor of polynomial equations. Then we can use long divisions to factorize and use factorization to factorize fully. So these are the example. Take a look. Okay, it is done and I pass 2.3 and 2.4 to Dinesh.